This video explores the engineering challenges created by earthquakes, how they form, the damage they cause, and how engineers design safer structures to withstand them. We'll begin with tectonic plates and the Earth's layers, then move to earthquake-prone regions like the Ring of Fire. We'll look at real examples including the 2010 Chile earthquake and the Alto Rio building collapse, and finish by comparing two major Chilean earthquakes. Earthquakes occur in the lithosphere, which is made up of Earth's crust and the uppermost solid mantle. This is where tectonic plates interact and release seismic energy. Earthquakes happen where tectonic plates meet. Plates can push together, pull apart, or slide past each other. Each type of movement builds stress in the crust, and when that stress is released, it causes an earthquake. The Ring of Fire is a horseshoe-shaped zone around the Pacific Ocean. It is one of the most seismically active regions in the world, where many tectonic plates meet and interact. February 27, 2010, Chile was struck by a magnitude 8.8 earthquake. More than 500 people died, and damages reached up to $30 billion. It was one of the strongest earthquakes ever recorded. One of the most tragic failures was the Alto Rio building, a 15-story tower that collapsed after its first-story walls gave way. The building split in half and overturned, showing how one weak point can bring down an entire structure. In our group project, we built a model using straws as columns and spaghetti as beams and braces. We focused on strong connections, a stable foundation, and a simple design, principle used in real earthquake-resistant engineering. I also studied the angle of repose, the steepest angle at which a pile of material remains stable. This concept is important in preventing landslides and in designing safe dams and slopes. The Las Palmas tailing dam is an example where soil stability and seismic forces must be carefully considered to prevent collapse. In the project, we measured the angle of repose of granular soils to see how loose materials can fail when a force is applied to them. After the force was applied, the sand dune settled into a less steep and more stable form. Studying the 1960 and 2010 earthquakes in Chile shows progress in engineering. The 1960 earthquake at magnitude 9.5 caused around 2,000 deaths due to weak building codes. In contrast, the 2010 earthquake, though still massive, caused fewer fatalities thanks to modern seismic codes and stronger infrastructure. In conclusion, earthquakes are natural events we cannot prevent, but through science, engineering, and strong building codes, we can reduce their impact and protect communities. Because earthquakes don't kill people, buildings do.